Okay, so we're given a set of transformations here, 3 transformations, and told to perform them on the parent function, the dotted black line. So I'm going to go through that. We're going to build an equation and find the domain and range. Now, when you're actually doing these things, what you may in time come to start doing is you figure out the starting point of this graph, which is the vertex of the parabola, and then you just move it over 5, down 1, and you make a new graph right there. And you squish it by a bit, right? It's supposed to be a little wider because of this squished factor of 1/2, the compression. That's not technically the right order to do these things in. And I want to go over the right order, even though it's a little slower, because that will make sure we don't find ourselves making mistakes with more complicated functions later on. So if you look at this one, I'm going to pick that starting point right there of 0, 0. And I love 0, 0 because when you do a compression on 0, 0, it's not going anywhere. Squish it by a factor of 1/2, it's still 0, 0. And now we move it over by 5, down by 1. Okay, so that point is going to right here. Next, let's find another point on this graph that I want to play with. And I'm going to pick over 2, up 4. And the reason I like over 2, up 4, instead of over 1, up 1, is because if I pick over 1, up 1, and then try to compress everything by a factor of 1/2, you're going to find yourself at a halfway point in between two numbers. It'll be y equals 1/2, which is not exactly a problem if you're drawing it by hand, but on the computer, it's going to force you to pick integer values. And it does that for your sake so that it saves you from making small, tiny errors when you're making graphs. But sometimes it is a little annoying that you can't use fractions. So I'm going to use over 2, up 4, because that will get me at a nice point right here when I cut it in half. It'll be over 2, up 2. So let's walk through this. Let me get these out of here. And over 2, up 2 will put me right here. Now I have to go down by 1 and over by 5 to 7. So that will be my final point right here. Okay, so that is how you do this, this graphing, this transformation. And once you have 2 points, the computer will say, okay, this guy knows what he's talking about. We're just going to fill the rest of it in. Okay, and the computer will draw this nice, pretty parabola here for you because you've shown that you understand what's basically happening in the function. Now, that's the picture. Let's talk about the equation. This is my original function, the parent function, f of x. And you guys know that that's x squared. Okay, you should be familiar with the shapes of these. But let's go through this and work through the transformations. First, I have a compression by a factor of 1/2. So it's going to be g of x equals 1/2 f of x. Okay, and what else is happening here? Well, we've got a vertical shift happening. And you know what? I'm going to try color coding these things. I've got a vertical shift happening down by 1. So that'll be a -1. And what else? There's one more thing. I've got a horizontal shift right by 5. So let's pull this over, give ourselves more room, and we can squeeze a shift right by 5 right in the parentheses. Remember, going to the right is a subtraction inside the parentheses. So this is our function notation answer. Okay, that's one thing this graph wants. If you were to scroll down there, that's one of the other things it's asking for. And then it wants to know the equation for g of x. Okay, not using function notation, which, here, let's back up a little bit. What is this thing? This f of, what is this right here? F of x minus 5. Well, if f of x equals x squared, then f of x minus 5 equals x minus 5 squared. Okay, and that means g of x equals 1/2 x minus 5 squared minus 1. That'll be your answer for the equation in regular equation form. Now, one more thing. Let's talk about domain and range. This should be pretty quick. Domain, if you think about all the x values that are allowed, it's everything, right? This thing is just going up into infinity, and that's going to be all the x values to the left, all the x values to the right. So this is just negative infinity to infinity, and the range is not 0 to infinity like the starting function. It's going to be -1 to infinity because the graph was shifted down.